What is the difference between a partial discharge test and a withstand voltage test? In the withstand voltage test, high AC voltage is applied to the DUT, and the leakage current that flows through it is measured and a judgment is made. In short, dielectric breakdown equals an increase in current, and the DUT that fails the test is in many cases damaged and unrecoverable. Additionally, if there is no breakdown in the withstand voltage test, the product is judged as acceptable, even if there are voids which cause insulation failure. Partial discharge testing, on the other hand, captures the increase in charge before dielectric breakdown occurs, so in most cases the DUT will not be destroyed. The relationship between partial discharge and dielectric breakdown is shown in the figure on the right. Partial discharge testing is an effective means of examining the insulation condition. When the voltage applied to the DUT is gradually increased, discharge begins at point A. Sparks are then generated and the process shifts to arcing, leading to dielectric breakdown. Between points B and C, partial discharge starts and then enters the stable region for a period of time, but a surge in partial discharge occurs from point C to D, leading to dielectric breakdown. In withstand voltage tests, the presence of dielectric breakdown is determined by measuring the current value in the area from point A to D, where dielectric breakdown is occurring, while in the partial discharge test, the presence of partial discharge is determined by measuring the minute increase in charge from the area from point A to D before dielectric breakdown occurs. In other words, since it detects the state before dielectric breakdown, it can detect potential defects and variations in manufacturing that cannot be detected by conventional withstand voltage tests. Furthermore, the following advantages can be expected compared to conventional methods. It is useful for optimization insulation design, reducing manufacturing variations, detecting material variations, improving safety, analyzing unexplained defects, and if defects can be detected non-destructively, investigating defective parts becomes possible. Now, let's see some actual partial discharge. Let's start the test. This time, we have prepared two transformers of the same type as test objects. Sample A is a good transformer, and sample B is a near defective transformer with poor insulation performance. After connecting the wires to the primary and secondary sides of the transformer, we'll set up the TOS 9301 PD. We'll set the test voltage to 1600 volts. The rise time, fall time, and test duration will all be set to 10 seconds each. Let's test sample A, which is the good transformer, first. The test voltage gradually increases, but no partial discharge occurs, and you can see that there is almost no movement in the amount of charge. This test was completed without any problem. Next, let's test sample B. As the test voltage gradually rises, partial discharge begins to occur around 1500 volts. And at 1600 volts, you can see that partial discharge is occurring continuously. In this instance, we did not set the upper charge value, so the test ended with a pass result, but in reality, if you set the upper value, the test will be interrupted with a fail notification. Next, let's see what happens when the withstand voltage test is performed on these two samples. First, we'll perform the withstand voltage test on the good transformer, which is sample A. The test conditions are the same as before and 1600 volts is applied. As you can see, we measured a small current value of 23 to 24 microamps, resulting in a pass. We know the product is good, and it is a normal result. Now, let's test sample B. In this case, as you can see, it also measures a current value of 23 to 24 microamps, resulting in a pass. In the withstand voltage test, it will be judged as a good product. However, in reality, as you can see, partial discharge is occurring and the product has the potential to become defective. But we were unable to detect this phenomenon only through the withstand voltage test.